Alright, this is an MTX3 5-speed transaxle, and we're going to talk about its parts, function, and power flows.
Okay, first part of the transaxles are gears. Gears come in three different types. They'd be a sliding gear. A sliding gear slides on the shaft and engages into another gear. The either gear mostly does this. There's integral gears, that's mostly on the cluster shaft. They're integrated into the shaft directly. Then there's freewheeling gears that slide freely and need a synchronizer to engage them to lock to the shaft.
For each gear set, there is a drive gear and a driven gear depending on the size of the gears, result in a torque multiplication or overdrive.
Alright, let's talk about torque multiplication and overdrive. Torque multiplication helps move the car forward from a stop position, whereas overdrive helps with speed multiplication efficiently, lowering the RPM of the engine at high speeds, also helping with gas mileage.
Depending on the drive gear and the driven gear and how many teeth are on each, correlates to the gear ratios. Normal gear ratios for torque multiplication is around 3.5 to 1, and direct drive is a 1-to-1 gear ratio. Overdrive is usually under 1-to-1, which is like a 0.8 or 0.9.
For example, a gear ratio 3 to 1 means the engine moves 3 times for every time the transmission moves 1 time.
We will now talk about the power flows of each speed of the transaxle. Now for first speed gear power flow. First, the first and second synchro sleeve moves one position forward while all other sliders are in neutral position. Power flow continues from the cluster shaft clockwise to the first speed gear on the cluster clockwise, meshed with the first speed gear on the main shaft counterclockwise to the clutch teeth counterclockwise, to the first and second synchro sleeve counterclockwise, to the hub counterclockwise, to the splines counterclockwise, all the way to the main shaft counterclockwise. It continues to the pinion gear on the main shaft counterclockwise that is meshed with the ring gear that's moving clockwise, all the way to the rivets on the differential, to the differential case itself, to the pinion shaft flipping over end clockwise to the pinion gears also flipping. These are meshed with the side gears that spin clockwise to the axle splines to the axle.
Now for the second speed power flow. First and second synchro sleeve move one position rearward, all other sliders in neutral. The power flow starts from the cluster shaft clockwise to the second speed gear on the cluster clockwise, merged with the second speed gear on the main shaft counterclockwise, to the clutch teeth counterclockwise, to the first and second sleeve counterclockwise, to the hub counterclockwise, to the spline counterclockwise, to the main shaft counterclockwise, to the pinion gear counterclockwise, and continue to the ring gear clockwise, to the rivet clockwise, to the differential case clockwise, to the pinion gear, to the pinion shaft clockwise, flipping clockwise, to the pinion gear clockwise, flipping clockwise, mesh with the side gear clockwise, to the axle splines clockwise. Now for the third speed power flow. Third and fourth single sleeve move one position forward, all other sliders in neutral. The power flow continues to the cluster shaft clockwise, to the third speed gear on the cluster clockwise, merge with the third speed gear on the main shaft counterclockwise, to the clutch teeth counterclockwise, to the third and fourth sleeve counterclockwise, to the hub counterclockwise, to the spline counterclockwise, to the main shaft counterclockwise, to the pinion gear counterclockwise. Continue to the ring gear clockwise, to the rivet clockwise, to the differential case clockwise, to the pinion shaft clockwise, flipping clockwise, to the pinion gear flipping clockwise, mesh with side gear clockwise, to the axle splines clockwise.
So now let's do fourth gear. Third and fourth synchro moves one position rearward, connecting the fourth speed gear on the main shaft to the main shaft. All other sliders are in the neutral position. Power flow. Cluster shaft clockwise, fourth speed gear on the cluster shaft clockwise, fourth speed gear on the main shaft counterclockwise, to the dog teeth counterclockwise, to the synchro sleeve counterclockwise, to the hub counterclockwise, to the splines counterclockwise, to the main shaft counterclockwise, to the pinion gear on the main shaft counterclockwise, to differential ring gear clockwise, to the case clockwise, to the pinion shaft, to the pinion gears flipping clockwise, to the side gears, to axle shaft. Now fifth gear. Fifth synchro moves one position rearward and all other sliders are in their neutral position. Power flow. Cluster shaft clockwise, fifth gear on the cluster shaft clockwise, fifth speed gear on the fifth speed shaft counterclockwise, to the dog teeth counterclockwise, to the sleeve counterclockwise, to the hub, to the splines counterclockwise, to the fifth speed shaft counterclockwise, to the pinion gear counterclockwise, to the ring gear clockwise, to the rivets clockwise, to the case clockwise, to the pinion shaft clockwise, to the pinion gears, to the side gears flipping clockwise, to the axle shaft clockwise.
And finally, for the reverse gear. The reverse idler gear slides forward one position, meshing with the reverse gear on the cluster shaft, also meshing with the reverse gear on the main shaft. All other sliders are in neutral position. The power flow starts from the cluster shaft clockwise to the reverse gear on the cluster clockwise, to the reverse idler gear counterclockwise, to the reverse gear on the first and second synchro sleeve clockwise, to the hubs clockwise, to the splines clockwise, to the main shaft clockwise, to the pinion gear clockwise, to the ring gear counterclockwise, to the rivets counterclockwise, to the diff case, to the pinion shaft flipping end over end counterclockwise, to the pinion gears flipping counterclockwise, to the side gears counterclockwise, to the axle splines, to the axle counterclockwise going reverse. The gear ratio is determined by dividing the number of teeth on the driven gear by the number of teeth on the drive gear.
After counting the gear teeth of this transaxle, dividing the driven gears by drive gears, we determine the following ratios.
The gear ratio for first speed is 3.6 to 1. For the second speed is 2.12 to 1. For the third speed is 1.39 to 1. For fourth speed is 1.02 to 1. For fifth speed is 1.02 to 1. Reverse is 3.62 to 1.
Fourth and fifth gear ratios are the same, but they use different pinion gears. The fifth uses a larger gear that creates an overdrive on the ring gear, which creates a final drive of 2.5 to 1 and an overall drive of 2.55 to 1, whereas the fourth gear, the overall drive is 3.4 to 1. This now is concluding the presentation of the Ford MTX3 transaxle.
Amen.